And now let's check out the second question. Given the John density function of f, x, and y, and first let's draw the non-zero definition region of f, x, and y. And we have known that y is greater or equal to 1 and x is greater than 1 over y and less than y. So we can plot it on the graph. That's like this. This is y, this is x. So the region which is shaded, that means the non-zero region, definite region of f, x, and y. And second, let's find a so that f, x, and y is valid. In order to make it valid, we should know that the integral in this whole space should be 1. That means integral from 1 to infinity and integral from 1 over y to y and times f, x, and y delta x and delta y. That means first we should integrate this inner term, inner item. Now y we should regard as a constant, so it's ln x over a times y squared, and y from 1 over y to y, and that equals ln y minus ln 1 over y squared. And we should factor out the 1 over a as a constant. And this item times delta y, and we integrate it from 1 to infinity, and we make it outcome equals 1. And it's like this. And finally, we should use a simple operation. Let's let t equals ln y. Then y equals e to the t, and delta y equals e to the t times delta t. So this formula becomes 2 over a times integral from 0, because when y equals 1, t equals 0, equal 0 to infinity, t over e to the t times delta t. And finally we get the answer like this. And so only when a equals 2, this would equals 1. So then that would make f, x, and y a valid joint density function. And third, let's find and draw the marginal density function f of x and f of y. We have known that f of x equals integral from minus infinity to infinity f of x and y times delta y. That equals 1 over 2 y squared x times d delta y. According to the graph, we know that if x is greater, if x is between 0 and y, x between 0 and y, given the x, the y should from 1 over x to infinity. So this is f sub x of x equals integral from 1 over x to infinity. So we find the answer equals 1/2. If x is greater than 1, y should integrate from x to infinity, and the outcome would be 1 over 2x squared. And the same to f sub y of y. It equals minus infinity to infinity f x and y times delta x. And for y is greater than 1, is greater or equal to 1, it should from 1 over y to y. Yeah. And times 1 over 2 y squared x times delta x. And the answer would be ln of y over y squared. And obviously, for y is less than 1, it equals 0. So we can plot it on the graph. It's like this. And this is also equal to plot. When x is between 0 and 1, it equals 1/2. And when x is greater than 1, it equals 1 over 2 times x squared. And next question, let's verify f of x and f of y are valid. So to check it, we just calculate its integral and to make sure it equals 1. So first, integral from 1 to infinity fy of y times delta y. Because we have known that y is greater or equal to 1, so the answer equals 1. So we can say the marginal density function f of y is valid, and we should do the same operation to f of x. An integral from 0 to 1, 1/2 times delta x plus integral from 1 to infinity, 1 over 2 x squared times delta x. It also equals 1. So we have known the answer is f of x and f of y are all valid density function. Thank you.